Welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 3 to the power of x squared plus 2 equals 27 to the power of x. Now what I'm first going to do is I'm actually going to replace 27 with 3 to the power of 3. Because remember, 27 is 3 to the power of 3. And we are powering this with x. So we have 3 to the power of x equals 3 to the power of x squared plus 2. Now, if we have something in the form a to the power of m to the power of n, this is actually equal to a to the power of m times n. So this is an important property of exponents. So if we have 3 to the power of 3 to the power of x, this is actually equal to 3 to the power of 3 times x, which is simply just 3x. And this is equal to 3 to the power of x squared plus 2. Now, because our bases here are the same, that means our exponents are the same as well. Because if we have a to the power of x equals a to the power of y, this means that x is actually equal to y. So that means that x squared plus 2 is equal to 3x. So now if I subtract by 3x on both sides, I get x squared minus 3x plus 2 equals 0. And now, as you can see, we have a quadratic equation, meaning we can find the solutions to this using the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac divided by 2a. So a is 1 because there is no coefficient here. B is negative 3 and C is 2. So now if we plug this into the formula, we get negative b, so 3 plus or minus the square root of negative 3 squared is 9 minus 4 times 1 times C is 2. And we are dividing this by 2 times 1, which is simply 2. Now, 9 minus 4 times 2 is 8, so we have 3 plus the square root of 1, which is simply 1 over 2, and we also have 3 minus 1 over 2. Well, 3 plus 1 is 4, and 4 divided by 2 is 2, so x equals 2 is one solution, and 3 minus 1 is 2, 2 divided by 2 is 1, so x equals 1 is another solution. So now, these two are our solutions to this equation. Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 2 to the power of 9 minus 2 to the power of 8 equals 4 to the power of x. Now what I'm first going to do is I'm going to rewrite 2 to the power of 9 as 2 to the power of 8 times 2 to the power of 1. Because remember, if we have a to the power of x times a to the power of y, this is equal to a to the power of x plus y. And I'm still subtracting this with 2 to the power of 8. And this is equal to 4 to the power of x. Now, since we have two terms with 2 to the power of 8, what I'm going to do is I'm going to factor 2 to the 8 out of this expression. So now 2 to the power of 8 divided by, if we take out 2 to the power of 8 from 2 to the power of 8 times 2 to the power of 1, we're simply just left with 2 to the power of 1, which is the same thing as 2. And minus 2 to the power of 8 divided by 2 to the power of 8 is 1. And this is still equal to 4 to the power of x. Now, 2 minus 1 is simply 1. So 2 to the power of 8 times 1 equals 4 to the power of x. Now, 4 to the power of x, this can actually be rewritten as 2 squared to the power of x. All we did was we replaced 4 with 2 squared. And this is equal to 2 to the power of 8 times 1 is simply just 2 to the power of 8. Now, an important property of exponents is that if we have a to the power of m to the power of n, this is equal to a to the power of m times n. So 2 to the power of 2 to the power of x, this is equal to 2 to the power of 2 times x, which is the same thing as 2x. And this is still equal to 2 to the power of 8. Now, because we have the same bases, then that must mean our exponents here, these two must be the same as well, because this equation would not be true if these exponents are different, meaning that our exponents are the same, meaning a equals 2x. And now, as you can see, we have a simple equation, and we just want to solve for x now. So if we divide by 2 on both sides, these two cancel out, and we get 8 divided by 2 equals x, and 8 divided by 2 is 4. So x equals 4. And this is our answer.